Okay, so hello everyone. Can you hear me? Hello. Okay, so now we will start our today's class. Okay, so basically today is our fourth number of class. I simply share my screen, then we will start our today's class. Just a minute. Okay, before that I simply start the recording. Okay. Okay, so now can you see my screen? Can you see my screen? Hello. Okay, let's go. Okay. Okay, so basically today I will try to discuss about the fourth number of class. In this class, I will try to discuss about that how you can easily remove the cloud from your satellite images. And this is our full course content. We try to complete all of the course content within the 7 days. How to remove the cloud from your satellite images. So mainly, previous class we also show that when you can work with the rainy season or wet season, we find out some cloud in our satellite images. So cloud is very hampered our land use land cover classification map. So that's why we also need to know about that how we can easily remove the cloud from the satellite images and get the very clear satellite images. Okay. Then we also try to discuss about the visualization of DEM data of hillshade map, salt map, how we can easily make the hillshade map, salt map, and aspect map from the NASA SRTM hillshade dataset. How we can easily use it and make the hillshade map, salt map, and how we can easily make the land surface temperature monitoring from the MODIS satellite imagery and make the time series chart. Okay, then how to calculate the average, maximum, minimum NDVI in a specific region. Suppose Dhaka city, you want to calculate the average NDVI of Dhaka city. What is the maximum NDVI of the Dhaka city? What is the minimum NDVI of Dhaka city? How you can easily calculate it? Okay, so let's go. So basically, when you want to remove the cloud from the satellite images, so here you can see this is the one satellite images. In this satellite images, we can find out some cloud such as white pixel value. It's identify the cloud. When I want to use here the cloud marks band function, then this cloud will be removed and I can get the very clear satellite images. Okay, so basically, it's depend on your satellite images. It can be Landsat or Sentinel. So mainly, we can remove the Landsat image and also remove the cloud from the Sentinel-2 satellite imagery very easily. The process is the same, but it has also some common difference in their band. Okay, suppose when you want to use here the cloud marks band function for the Sentinel, this band name is the QA60. Okay, so we can show the practical all of the things, then it also better. Just I simply open my code editor and then try to show you this part, how we can easily work with this. I just simply open my code editor and try to show you that how we can easily remove the cloud from the Sentinel-2 satellite imagery. Okay, so first of all, I simply import my image collection for the Sentinel-2 satellite imagery. So just I simply open my image collection. If you want, you can simply search your dataset. I simply search there Sentinel. Now it finding our dataset. So I want to work with the multispectral instrument, this dataset, and try to remove the cloud from the satellite images. So here you can see all of the information about this dataset, and also you can see the all of the band. And here we can find out the one kind of band. This band name is that cloud marks band QA60. So mainly when you want to remove the cloud, we need to work with the QA60 band, cloud marks band we need to use. And then we need to some filter in this band, then easily remove all of the cloud. Okay, so in this time I want to work with this satellite images. So just I simply import my image collection. Okay, so now this image collection is imported. Okay, and I need the satellite image, suppose Dhaka city region. So just I simply import my also my region such as Dhaka city. I simply import the Dhaka city new shape file, simply import it and put this name. You can use any name, so I simply put this name, suppose ROI. and also put this variable name, suppose Sentinel. You can use any variable name as a variable you can use. So in this time, I just filter my image collection according to my region. So it's very easy. Just we can simply use here the filter bounds function, filter date function, filter metadata function. Then we can filter our image collection. Okay. So let's just I simply take a variable. Suppose this variable name is that I simply put the variable name suppose image. Okay. And then I simply call my image collection. So image collection is the Sentinel 2. Okay. I need to filter bounds function. Filter bounds in this time I want to need this satellite image only for my region of Dhaka city. And Dhaka city shapefile is stored in a variable. This variable name is that ROI. Okay. So now I just simply filter bounds according my region. And then I also need to filter according to my time period. So just I simply put here the time period. Suppose I need the time period filter date function and put here my specific time period. Suppose I want to work with the year of 2016, 1st January from, I take the whole of all of the image for year of 2016. So December 31. Okay. In this time, I just simply filter this date. And then I also need to filter this image properties. Okay. So I simply use here the filter. Then I can use here the Earth Engine filter. Suppose in this time I use here the less than LT, less than. In this time I simply put here the suppose image properties name. I want to use here the cloud pixel percentage. Suppose image properties, I simply copy the cloud pixel percentage. And then I simply put here and then set the value suppose 1. Okay. So in this time it filter cloud pixel percentage, which image is the less than 1% cloud cover. I can get only for this image. Okay. Or if you want, you can use the filter metadata function. Then use the same process also. Suppose you can use this type function. Suppose filter metadata. Also, you can use the same tags. There is no any difference. Filter metadata. Filter metadata. Filter metadata and put all of the name operator value. So name is the cloud pixel percentage, operator is the less than, and value is the 1. And in this time, I can use here this directly filter, Earth Engine filter less than, cloud pixel percentage less than 1. Okay, then I simply put the value. So they are the same, okay, the same function. In this time, I use here this one. So I simply move it on for this time. Okay. Okay. So in this time, I want to create all of the images which less than 1% cloud cover and create the median composite. I simply use here the median. Okay. And then simply use here the clip function. Clip. Okay. Clip with my shapefile is that ROI. Okay. So now show the result. So I simply use here this map dot add layer function and then call the image, this object name, and click to the run. Now a new layer will be added, but I did not see the my area. I simply use here the map dot center object, and I want to focus the center of the shapefile. Shapefile is that ROI, and put the zoom level suppose 10 and click to the run. So now you can see we can get this satellite images in here look like this. I did not add any visualization though, that's why it looked like this. So in this time I want to add here the visualization. So for that I simply use here this setting button and then simply put here this suppose red band, then green band and blue band, and then custom 98% stress and then apply. Okay. Okay. In this time, I can get some haze on the satellite images, you can see, but they're not much cloudy. Okay, this image is not much cloudy. So I want to increasing the cloud of the satellite images. So that's why I simply use here the less than suppose 90%. Okay, then it also increasing the cloud. Okay, so I simply click to the run again. and then try to add the visualization again, then find out some cloud in this satellite images because I increasing the value. So I simply click on here and then set the value such as red, then green, and blue. It's just 98%, then apply. So now we can observe some cloud in this satellite. Okay, so now we can see we can get the some cloud. Okay, we can get the some cloud white pixel value in here. So in this time, my main target is that I want to remove this type of cloud and also this type of haze. I simply remove and then get the clear satellite images. So in this time, you can see when I use here the less than 1%, then I can get the less cloud. But in this time, I use here the 90% cloud cover. So sometime when you want to work with the some coastal area or riverbank area for the satellite images, this type of satellite images, you did not find the less than 1% cloud cover. You can see there is the zero. There is the no image is available which are less than 1% cloud cover. We can get the totally zero result. There is the no image. Okay. Less than 1% cloud cover is not available. Then you have to increasing this value and find out this satellite image is available or not. Okay. Some coastal area or river bank, you can find out there is the no image, less than 1% cloud cover image. There is the not available for this coastal area or river bank or river area. There is the no, less than 1%. Then you need to increasing the value. But when you increasing the value, then you can get the some this type of cloudy image. Look, this type of cloudy image you can find out. Okay, but you also need to remove the cloud. Okay, so in this time I try to show you that how you can easily remove the cloud. This type of cloud, how you can easily remove. Okay, so let's go. So I simply import this visualization in here and then simply copy. Okay, and after paste after the object name. So my object is that image. After the image, I simply put this object. So now this visualization will be set with my code. Okay, so let's go. In this time, when you want to remove the cloud from the Sentinel-2 satellite images, first of all, we have to show the cloud marks band. You can see it has this image collection has also another band. This band name is that QA60. Okay, so QA60, this is the cloud marks band. Okay, and QA60, this band has 2 bit, mainly 3 bit, but unused. You can see 0 to 9, it unused, but we can use only for the bit 10 and bit 11. Okay, bit 10 has also some signal 0 and 1. 0 is identify no cloud, or 1 is identify cloud present. Okay, such as also you can see the bit 11, it is the cirrus cloud. 0 signal identify there is the no cirrus cloud, and 1 is identify cirrus cloud present. Okay, so in this time I make a function. This function, first of all, select the QA60 band. After that, select the bit 10 and bit 11. Then it also select the 0 and also select the 0 from the bit 10 and bit 11. Bit 10 equal to 0 and also bit 11 equal to 0. So it's identify the clear condition of this satellite images. Okay, so first of all, I just simply select the QA60, this band. From this band, I simply select the bit 10 and also select the bit 11. From the bit 10, I select 0 and also from the bit 11, I select 0 signal. Okay, then it identify the clear condition and we can write the function for creating all of the things. Okay, so let's go. So first of all, I just simply create a function in here. So I can put a function variable name. You can use any variable name. Okay, so I simply take a variable name. Suppose I put the variable name is that max to clouds. You can use any variable name. Okay, then use here the function keyword. Function keyword I can simply use. After the keyword, I need to put here the element name. So in this time, I take only for the one element. Suppose image. Okay, then use here this curly bracket. In this curly bracket, I put my argument. My first argument is that I need to select QA60 band. So I simply take a variable. Suppose this variable name is the QA, and I simply call the image. From this image, I need to select the band. My band name is that. I simply copy the band name from here. Suppose you can see this band name is that QA60. QA60. I simply copy the band name and then I simply paste here. Okay. And then from the QA60, I need to select the bit 10 and bit 11. Okay. So for that, I simply take a variable. Suppose this variable name is the cloud bit max. I simply put here the 1 less than 10. So this is the symbol when you want to select any bit. Okay, bit 1 less than this is the bit 10. I simply select. The same process, I take the another variable, suppose cirrus bit max, and use here the 1 less than bit 11. Okay, in this time cloud bit max, I want to select the signal 0, and also cirrus bit max, I also need to select the signal 0. So it's identify the clear condition. So for that, I simply take a variable. Suppose this variable name is the max, and then I simply call the QA, my band name, so QA, and use a function. It's called the bitwise end with cloud bit max. I simply call this variable name, copy and paste here. Cloud bit max, I simply set here the equal to 0. And then also use here the another function, another bit max. I simply use here the end function. In this function, I simply call the QA this band and use here this bitwise end, and then call this cirrus bit max. Simply paste here and then use here the equal to 0. I simply select this 0 signal. In this time, you can see I write my function. In this time, I need to update this image. Basically, when you want to write the function, finally you return the function what you can get. Okay, so in this time, I just simply add here this another thing. Suppose I simply use the return function, and return this image, and use here the update max function with my these things. I simply copy. I need to update according to this algorithm. So I simply copy this variable name and paste here. Okay. So now this image is the update. So in this time, I create my function. Basically, this is the function. This function is the cloud max band function I created. In this time, this function I need to add with my image collection. Okay, this is my image collection. Okay, so when I want to add this function I added with this image collection, that it automatically remove all of the cloud and haze from the satellite images. Okay, so in this time, I want to create the another layer. So for showing the cloud free image, so just I simply use the same code. So I simply copy the same code from here. Okay, and then simply paste here. Okay, I simply put this name, suppose image cloud free. You can use anywhere cloud free. Then I simply add this another function. So I simply use here the map function. After the map function, I simply call this variable name max to cloud and paste here. Okay, so now this function is added with my whole image collection. Okay, so let's go. Now we try to add here this layer and try to show this image. So just I simply use here the map dot add layer and then call this image cloud free. This is my object. I simply copy and paste here. Okay, then click to the run. Okay, so now we can get the another layer in this time. Okay, this is a cloudy image. We did not add the cloud marks band function. And when I want to add the cloud marks band function, another image is created. Then we can see there is the no cloud. In this time, it's showing the default visualization. So I want to add here the visualization such as I want to add here the suppose default red, green, and blue band, and increasing the custom 98%, and then apply. Okay. Okay, so now you can see I also added the import this visualization in my code editor, and then copy, and after that I simply paste after the object name is the cloud free image. I simply import this, okay, and also put the layer name suppose cloud free, okay, then click to the run. So now you can see same image, but one image collection I did not use the cloud marks band function. That's why I can find out some cloud. But when I use the cloud marks band function, I can get the very clear satellite images, and all of the cloud and haze is the removed. So you can see there are the two layer. So cloud free, this image collection, I use here the cloud marks band function, but the second layer I did not use. So that's why you can see second layer, you can find out some cloud. Yes, so it loaded, you can see. And another layer also loaded. You can see that it has also some cloud. In this time there is a no cloud. Okay, and we can get the very clear satellite images. Now we can use these satellite images for making the land use land cover classification map very easily we can do. So you can see first time I can get the some cloud in here. You can see cloud. And second it will be removed. So this is a cloudy image. You can see cloud, also cloud in here, also cloud in here. So but when I want to simply use here the cloud mask bank function, you can see all of the cloud will be removed. And also haze, all of the haze also remove. We can get the very clear satellite images. But we are also use here the 90% less than 90% cloud cover. Okay, so you can see some region when you want to work some coastal area or river bank, then you did not find less than 1% cloud cover image. Then you need to increasing the value 90%, 50%, and when you increasing the value, then you can get the some cloud look like this. Some you can get the some cloud. But when you are using the cloud mask function, you can see all of the cloud will be removed. Okay, and get the very clear satellite image. In this time there is a no cloud, but when you can see the another layer is the cloud. Okay, okay, so anyone any question in this time you can ask me any question. Okay, so in this time you can see for the Sentinel-2 satellite imagery we are using here the cloud mask function name is the QA60. Okay, so I simply make a function. In this function I just simply select the QA60 band. QA60 band, I didn't it's called the cloud marks band. In this time this QA60 band has a 2 bit, bit 10 and bit 11. Okay, so I simply select the cloud one variable and store the bit 10 and take the another variable and store the another bit 11. Okay, then I simply use here the QA. So this is my bit band name, QA60 band QA, and I simply store the variable QA. So I simply use the QA. Then bitwise AND function. So mainly this function we can use when you want to add the bit with your band. Okay, so QA60 this band has a 2 bit, bit 11 and bit 10. Okay, bit 10 has a 2 signal, 0 and 1. 2 signal is available. So I simply use here the equal to 0 because 0 is identified there is the no cloud, or 1 is identify cloud present. Okay, also do for the same thing for another slash bit marks. So I simply use here the AND function and also add here the QA. I simply call this band and use here the bitwise AND, simply call the slash bit marks and set equal to 0. 0 identify there is the no slash cloud. Okay, and all of the things I need to update. Okay, so I simply use here the return function and simply call my element name is the image and use at the update marks. Now, what's the algorithm or what's the function I use for updating? I updating all of the things according to the all of the things, and all of the things is stored in a variable marks function. So I simply use the marks variable name in here. Okay, so now this is my cloud marks band function. When I want to add this cloud marks band function with my image collection using the map function. So mainly map is a function, it adding the your function with your image whole image collection. So in this time, this is my whole function. You can see this function variable name is the cloud marks to cloud. When I want to add this map function and add this marks to cloud function, then it automatically added and it automatically remove all of the cloud from the satellite images. Okay, anyone any question? Yeah, so it also available some cloud. So 100% is not available because in this time, this for this region, we are also apply for the less than one. Suppose when I want to use the less than one, then it will be automatically removed. But it this algorithm is the apply when you want to some coastal area, there is the no image. Suppose less than one image is not available, then you can easily apply and easily remove the all of the cloud. Okay. So, but yeah, yeah, please. Yeah, of course, it's available for the sequence. So sequence is that you can see, first of all, I need to use here the filter bounds function. Okay. After that, you need to use here, you can use here the filter date, or you can also use here the this function filter metadata or filter e filter dot less than you can use. But you can see map function you did not use after the median function. Okay. So you need to apply this map function after filtering. So mainly you can see this is the it's identified the where. So where is the place, and it's identify the when, and it's identify the how. Okay, so you can see it is the where is your region, then you need to identify the when is your time period, and then how is that how many cloud pixel you want to need. So after when or where when how, you can use any you can put this function anywhere. Suppose you have the filter date function in here, there is no problem. There is a no sequence for the where when how. Okay, there is a no sequence. Suppose you want to use the filter date in here, there is a no problem. But when you want to put all of the things, then you need to use the median function. Okay, but when you want to use the map function, or you created the some external function after when where how, then you need to put here this map function, then it will be work, otherwise it not work. Okay, so where when how, you just maintain the sequence, then you can simply put here the map function, then median, then clip, then it will be work. Okay, any question? Select mean you need to select some band. Okay, okay, so after this you can also need to use here the some select. Okay, so after this you need to have the select. Okay, you need to select all of the band in here which band you want to need. So when where how, then you can simply select this select all of your band which you want to need. Okay, and then use here the map function, then median. And when you want to, suppose in this time I simply use here this map function after the median, then you can see what happened. You can check it. So I simply put the map in here and then simply call this variable name. You can see it's showing the problem. It's showing the problem look like this. Filter median map is not a function. Okay, you can see map is not function in this time. Okay, so after the median you did not use the map function. So mainly why you can use the map function? Map function you can use so that all of the image has all of the cloudy pixel value will be removed. Okay, you can see in this time when you can create the median, it create only for the one median image. Okay, in this time it create only for the one median image, then you can use the map function. So that's why it's not work. So for this I need to use the map function in here. I need to use the map function after filtering all of the images. In this time, when you want to check how many images is available, all of the image, I apply this cloud marks band function. All of the image. Suppose you can check it. Suppose I simply check it how many images I want to get. I also remove this guys. Okay, so I simply print this image. So print, suppose this image cloud 3, and then simply use the size function. So now it identify how many images is available for this region. 60. Okay. I need to apply total 60 images for the cloud marks band function. I need to apply total 60 images. Okay. So that's why I simply use the map function in here. But when I want to use here the median, I use the median and then I use here the map function. Then what happened? First of all, it created only for the 60 images median value and create the one composite. Okay, so that's why when I run the code, you can see in this time it's showing that its map is not function. Okay, so but when I use the map function in here, and then after the map function, I simply use here the median function, then it will be work. Okay, any question in this time? You can ask any question for the sequence. Yeah, it's also follow the same process also mosaic. So in this time you use the median, you can also use the mosaic. Okay, also same process for the mosaic or mean or median, anything. Okay, just follow the sequence. Okay, any question? Okay, any question? Or any doubt about? Okay, so in this time I simply go to my next slide. So in this time we try to discuss about this part, how we can easily. Okay, so now I hope you can easily understand about that, how you can easily remove the cloud from your satellite images and get the very clear satellite images. Okay, so if there is no question, then we can easily go to our next slide and then try to discuss about our next topic. So let's go. Okay, so in this time I try to discuss about that, how you can easily make the land surface temperature from the satellite images. In this time mainly we are using at the MODIS satellite images, and then try to make the time series chart. Look at that time series chart, how you can easily make. Okay, so for this I simply open the new code editor. Suppose I simply open a new code editor. Okay, suppose in this time I want to make the time series chart for the land surface temperature for whole country boundary of Bangladesh. Okay, and also make the land surface temperature map for the whole country boundary of Bangladesh. And I want to use here the MODIS land surface temperature. So data set. So for that, so first of all, I simply import the image collection. Suppose I just simply use here the browse data catalog and find out my data set. So in this time, I just simply click on the MODIS. In this time here you can get all of the image collection for the MODIS. Here you can get the MODIS two type of data set for land surface temperature monitoring. Two types of data set we can get, you can see for the MODIS. So one type of data set you can see land surface temperature daily. Mainly this data set daily data set. This data set is the updating daily. When you are using the data set, you can get the every single day data for land surface temperature. For every single day data you can get, because this data set is the daily. But you can see that data set, we can get the data set such as every 8-day interval time period. Every an average 8-day land surface temperature we can get. Okay, so this data set, the same process when you use the 8-day or daily. When you are using the 8-day, it created the time series chart as a 8-day time interval. Suppose 1st January, then we can get the another data set for the 8th January, then a 16th January. So every 8 day. But when you are using here the global data, daily data set, you can see this is a daily data set. Then we can get the every single day land surface temperature data. You can get 1st January, 2nd January, 3rd January, 4th January. Every single day you can easily get. Okay. So, and the same process when you want to apply for the 8 day or daily for making the time series chart or make the map. So for all of the things will be same process. So let's go. So suppose in this time I try to show you the 8 day, but you also try to for your own self for making the time series chart for land surface temperature daily. Okay. So let's go. Just I simply open the data set. So here I can get all of the information about this data set. Here you can see the data set availability date. We can get the data set between this time period. Also you can see the data set provider. Okay, this is the artisan snippet. Okay, so in this time, first of all I just simply import this image collection. Also you can see this data set scale 0.02. When you can find any data set has a scale, you must be reprojected this scale value. So when we are working for the modis NDVI, we also apply here the modis NDVI reprojected scale value. We need to multiply with 0.0001. So in this time we can get also the scale. So that's why we also need to multiply with our scale value when I want to work. Okay. So let's go. So first of all, I simply import this image collection. I simply copy and paste in my code editor. So I simply put a name. Suppose this variable name is that modis LST. Okay. And now it will be imported in my code editor. In this time, I just need to also import it the boundary shape file. Okay. So just I simply import the boundary shape file. Such as suppose Bangladesh boundary shape file, I simply import. So I just simply import the Bangladesh boundary shape file. And I already imported this shape file in here. Okay, just I simply import. And I simply put this name such as ROI. Okay. Okay, so in this time, I want to filter this image collection according to my region. So first of all, in this time, I also use here the another function. It's called the date range function. How you can easily use the date range function, I also try to discuss in this time. So mainly, date range function, when you want to put any date range, suppose 10 years, 5 years. So let's go. Practical example. So I simply take a variable. Suppose this variable name is that start. Okay. And put here the start date earth engine date. Okay. And put here the value, suppose 2014 January. Okay. So this is my start date. Okay. In this start date, I also need to create the date range function. So for that, I simply take a variable name, suppose date range. Okay. In this function, I just simply add here earth engine date range. Sorry. I simply find out the date range function in here. I did not remember the function, what the spelling. So date. Okay, EE dot date range. So I simply use here EE dot date range. Okay. And you can get the argument. You can see start date, end date, and time zone. So in this time, I simply put here the start date, such as suppose 2014 1st January. So I simply call the variable name start and paste here, same variable. The end date, I want to put here the end date, such as I need to add here the advance 1 year, or advance 2 year, or advance 4 year, or advance 10 year. So that's why I simply call the start and paste here and use here the advance function. So advance. Suppose in this time I put here the delta and unit. So I simply put the delta. Delta is the value. Suppose I need the time series chart for the advance. Suppose 2 year. I simply put it the 2 and put here the unit. Suppose unit is that year. Okay. So in this time, what happened? You can see I use here the advance 2 year. So it will be start from the 2014, then 15. So I can get the time series chart from 2014 and then 2015. So at advanced 2 year I want to get in here. Suppose in this time I want to use here the advanced 2 month. So I simply month. In this time I can get the data set from year of 2014, first January, then February. So 2 month, January and February. Okay, I can get when I use here the month. You can also use here the day. Then it advance the 2 day look like this data, so you can get. So in this time, suppose I want to need the advanced 2 year. So I simply use here the year. If you want to need the advanced 5 year, simply put at the 5. It will be moved to the 5 year from year of 2014, then 15, then 16, then 17, then 18. Okay, we can get the data set from the 18. I use here the advanced 5 year. Okay, so in this time I simply remove it not for this time, and also not for this time. So in this time, what happen? You can see I can simply use here the start date. This is my start date. I want to use here the date range function and then put here the start date. And from this start date, I want to get advance 5 year. Okay. So in this time, I just simply put here my image collection in here. So I simply take a variable. So I simply put the variable name, suppose mod LST. So in this time, I just need to filter. I just simply call this image collection. I simply call this modis LST. Okay. And this image collection has a lot of band. From this lot of band, I need to select only for this specific band, such as you can see, I want to work with this band. This band is that land surface temperature day 1 kilometer. And this unit is the Kelvin. We can easily convert the unit in degree Celsius. Okay, so we also try to show you later how you can easily do this. I simply copy, okay, and then paste here. Okay, after this, I simply use a function. It's called the filter date function. Filter date, and in this time you can see I simply put here the start date, filter date. Okay, not that. I simply put here. You can see start date and end date. So anyone can guess it in this time. What is the variable name I need to use here for the start and end date? Anyone can guess it? What's the variable I need to use here? Yeah, date range. Okay. So in this time, I simply remove all of things. I simply use here the date range function, date range variable, because in this date range, I define, you can see start date and also define here the end date. Okay. End date mainly it will be start from advanced 5 year. Okay. Just I simply copy the date range and simply paste here. And paste here. Okay. So now you can see here what happened. I want to check how many images I want to get. So I simply use the print function and then check here the mode LST and use here the size function and click to the run. Okay. It's a string. You must be using the single quotation or double quotation. Then click to the run again. So now you can see we can get the 230 images for the 5 year. We can get total 230 images. So in this time, from if you want to check the time period, you can see if you want to check the time period, all of the images, just I simply print this. We can get the each images time period is that 8-day interval time period. You can see. So when I want to simply open this, you can see the total feature. Here I can get You can see 1st January, 9th January, 17th January, 25th January. So every single image you can see what is the time period interval from first image to second image. We can get the 8 day. Second image to third image we can get the 8 day. Third image to fourth image we can get the 8 day. So every 8 day interval we can get this all of the images. Okay. So in this time when you make the time series chart we can get the only for the 8 day. Okay, 8 day time period chart we can create it when I work with the land surface temperature. Okay, so in this time I just need to make the image. So I want to make this, suppose I just simply add here this, suppose I simply use here the map dot add layer and then try to add here the mode LST and paste here and click to the run. In this time you can see I get the result, but I did not use any reducer. Okay, so mainly you can also try to apply without reducer. You can just use at the map.add layer function and apply this code. You can get the wrong. Suppose when you want to work with the modis ndvi, you also try to for your own self. I hope you can get the wrong. You can see modis ndvi. When you are using the dataset for the, suppose this dataset you want to use for the modis ndvi dataset, you can use, and without reducer function, mainly without calculating the mean or average all of the pixel value, you can try to run this code, you can get the wrong. But in this time I did not get any wrong. Anyone can guess it why it's happened in this time, why I did not get any wrong, but I use here the directly without reduce function I can use it. So anyone can guess it why I did not get this wrong in this time. Okay. So this question answer is that in this time, it already created the average result. You can see this product provides an average or mean average 8 day land surface temperature. So it already created the 8 day average composite. So that's why in this time, when I want to add here the directly map.add layer function, it will be work. Okay. So in this time it will look like this. So that's why I need to add here the visualization. I just simply add their visualization from here. Suppose I simply copy this visualization code from here and paste in my code editor. Okay. After that, I simply copy this visualization, simply copy and paste the object name and click to the run. So now you can see it represented the whole world land surface temperature map for total 5 years from year of 2014 to advanced 5 year. We can get the whole world land surface temperature. Okay, you can see we can get the result. In this time, this unit is the Kelvin. We can easily convert the unit such as degree Celsius, and we also need to reproject the scale value because you can see they already provide the scale. This scale is that you can see 0.02. We need to multiply all of the images with this scale factor when you want to work with this. So in this time we can see we can get the result. You can see whole world land surface temperature map. We can create it. In this time I don't need for the all of the whole world. I need only for the specific country or a specific boundary for this map. So I need to click with my shape file. Then I can easily get the result, and then I can easily make the time series chart. All other things we can easily handle. Okay. So let's go. In this time, anyone any question in here? You can ask me any question or need out. Yeah, please. Yeah. Yeah. We can also use the lens set. Yeah. Yeah. Yeah, 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 yeah. In this term, you can see for the Lancet, I also try to show you the algorithm, Lancet LST. I simply search on here. Here it will be provide me some algorithm. So just I simply try to show you the algorithm. We can easily use this algorithm and try to make the land surface temperature map also in Google Earth Engine platform. So basically this data set is not ready. So that's why we need to write the code, and I already write the code for the Landsat land surface temperature monitoring. So I simply open this. Okay, so you can see this is the one kind of algorithm for Landsat 8 dataset. How we can easily use the dataset for making this land surface temperature using the Landsat. You can see. So this is our algorithm. So in this algorithm, what happened? You can see that we are using here the Landsat 8, and from the Landsat 8, there use here the two type of data, and from OLI dataset, satellite imagery, then you get the near infrared band and red infrared band, or calculate the NDVI, and also you can see this from this data they can get the thermal band or band 10, and from this they calculate the top of atmospheric spectral radiance. Okay, then they calculate the brightness temperature or TB. From the NDVI, they calculated the vegetation proportion, then calculate the surface emissivity. Okay, all of the algorithm we can easily develop in Google Earth Engine platform and get the result from the land surface temperature. So after that, I also try to share the code with you so that you can also try to understand about the code and also try to understand about the algorithm. And you can easily apply this code for your other region for make the land surface temperature monitoring using the Landsat 8 imagery. Okay. But Modi's dataset is already ready-made dataset. This dataset is already ready-made, so that's why you can easily use the Modi's dataset. But this Landsat dataset is not ready-made. Okay, so in this time we need to use out this. Yeah, yeah. Yeah. Okay, okay, okay. So I also try to share this code with you, and also same algorithm we can also apply. And you also try to read this paper, then you can also get the better idea about this algorithm. Okay, so let's go. So you can finish our first of Modis thing, then we'll also try to discuss about the code. So okay. So in this time, you can see I just simply add this whole LST map. So in this time, I don't need for the whole world. I need only for the country boundary of Bangladesh. So just I simply click, then I can get the result only for the country boundary of Bangladesh.